So previously we've implemented a locale switcher that works based on cookies. However, our goal was always to retrieve the locale from the path name, so eventually we would like to use path names like US or MX. Now to get started here, in this lesson we'll set up locale based routing like for example ENUS or ESMX. So let's see how we can do that. To get started with this routing structure, we can add a top level folder within our app directory. And since this will contain all of our locale values, we can call it locale. And within this folder, we're going to move all of our existing routing structure. Now to make my job of doing this a little bit easier, I'm simply going to rename my app directory to locale. And now I can add a new app directory, take our locale folder and move it within it. Now if we reload our app, naturally we'll see a 404 page since we don't have a root page anymore. However, if we navigate to a path name like ENUS for example, our app still renders just fine. As a side note, you can also use a different routing structure, but by using a top-level locale segment, NextIntl can help you the most. But back to our app, while we're displaying a locale in the path name, we're not practically using it on the page. So if we switch to ESMX for example, we're still rendering in American English since we're not incorporating the locale anywhere. So let's change this. And for this, let's navigate to our i18n request configuration where we're currently initializing our app locale from cookies. But now instead of reading from cookies, how can we read the locale from our path name? To read our locale from the top level locale segment, we can add another import for next root params. And from here we can import individual params, like for example the locale. At the time of recording this video, to use this feature we need to hop over to our Next.js configuration, and here we need to add a new configuration option for experimental root params true. But with this we're ready to go. To avoid a naming collision with our existing locale, I'll simply import all of the root params. And now to retrieve our locale value, we can read from await root params.locale. And after saving, on the right hand side we see that our app immediately switches to Spanish since we're using ESMX in the path name. And similarly, if we go back to ENUS, we'll see that we're rendering again in American English. But let's take a step back. What exactly happens in this line? If you consider the most basic Next.js app, it might look like this. So here we have a page at the root and also a layout. But what happens if we introduce a locale folder? So our application root is still this page and this layout. However, we're nested within a locale folder. Now to read values from these top level segments, Next.js has introduced next root params. And this is a module where we can import by a segment name like locale and then use this as a function which we can await to retrieve the current segment value. So that means the return type of this value is a string in this case. But what happens if we add more routes to our application? Like for example a stories segment and within this a slug segment. So here we might add a new page as well, but also a layout. So since there is a second dynamic segment, can we now import slug as well here? Actually, not quite. The root params API is only intended to read the segment values of root layouts. And root layouts are only the ones which don't have other layouts located above it. So in this case, this will be our root layout. And if we look at our other layout here, then this will be a regular layout. So this is the most important aspect to keep in mind when using next root params. But let's make this a bit more interesting. What if we add another page outside of the locale folder? Here we might have another page. And as every page also requires a layout, we need to add one here as well. So what happened now is our previous layout is no longer a root layout. Instead, our new root layout is this one here. So now there's still one root layout, but two regular layouts. A practical application for this page outside of the locale folder is to introduce a country selection page. But it would be quite a pity if it no longer allows us to read the locale from next root params. So how can we make our root layout this one again? The only way to do this is to move this page and the layout within a folder. So using something like country selection would of course work, but what if we actually want to use the root? There's another feature from Next.js which comes in handy here, and these are route groups. So if we create a folder with the name in brackets, we can use an arbitrary name here, like for example root, or since this is outside of our locale, we could also call it unlocalized. So by definition, since our locale layout no longer has another layout located above it, it can remain a root layout. But what about this layout? Is it a regular layout or a root layout? Well, the same definition applies, right? There's no layout above it, so in this case we have two root layouts. However, for our code below, this doesn't change so much, since we still only have one top level segment. From unlocalized we can't read any values, only from /locale. But what happens in case we use next root params, for example on the home page? In this case, since there is no locale segment present, this means our locale is now typed as string or undefined, depending on where it's called from. So there's probably not much use on calling next root params on the home page. But if you consider that you might have shared code, like for example a getLocale function, and let me move this side by side so we have a bit more space. We can use this function either within the locale segment or outside of it. And for the case of calling it on our homepage, it might make sense to consider the undefined case. So if we don't have a locale, we can assign it with a default, like for example enus, and then return it. So while the country selection page might only be available in a single language, it can still be useful to use features from Next.intl like translations, date and number formatting and more on this page. So having such a centralized logic can be quite handy for your code base. And when using Next.intl, the I18N request module is exactly the equivalent of the central place for reading your locale. So if we want to handle a fallback as well here, we can check that if no locale is present, then we can assign it to a default of enus, for example. But also, we don't want to support any locale that might be present in the path name, but only our known path names. So to define the locales available for our routing, we can add a new file at routing.typescript. And here we can define a routing configuration by using a helper function from Next.intl and then defining all of the locales that we support. So in our case, enus, esmx, enca, and frca. Also, here we can define a default locale, which is one of our available values, and let's pick American English here. And now, back in our request configuration, let's clean this up and assign the result here to our param value. Now we can define our locale by using another utility that checks within our routing configuration if our locales include this particular param value, then we can use it. And if not, we can fall back to our default locale. So with this, we now have some validation in place which always returns a valid locale. You might be wondering if you could also call the notFound function here in case you're receiving a locale that is not supported. And this would absolutely be possible, but based on my experience, it's a good idea to always return a correct locale here and handle the validation in your root layout. And we'll look into that in a minute. So let's remove this. The important point is we're now reading our locale from root params and returning a valid locale based on it. And if you remember, in our root layout, we're using Next.intl client provider, which takes our server provided locale and passes it to the client side. So that means the single source of truth for reading our locale is the path name, and this is propagated throughout all of our application. So as you can see, for locale-based routing, instead of relying for example on cookies, the root params API is exactly what we need. There's one final note here to be made before we wrap up this lesson. The Next root params API is very new at the point of recording this video, and some details are still being fleshed out. For what it's really helpful to be used at this point is in server components. And currently, Next root params has a limitation of only being used during the server components render. So that means all markup which appears on the page is fine, and also metadata. However, what's not supported at this point is server actions and route handlers, but we can easily pass the local manually for these cases. So let's have a look at an example. In the footer of our application, we have this form for subscribing to the newsletter. And this uses the getTranslations function to return human-readable labels in case there are validation errors. So when we call getTranslations, behind the scenes our i18n request configuration will be consulted. And now to avoid calling root params there, we can provide an explicit local to this function. So this can be turned into an object where this is our namespace. And now we can explicitly provide a local. So how you're providing this local is entirely up to you. But in case of server actions, a simple mechanism is to use bind, which is a utility for providing additional arguments to this action. And here we can now set our local, which we can retrieve during the render of this component. And now our action will be prepended with the local. And after this, the final missing piece is to go back to our request configuration. And now we can accept an override for the local, which corresponds to the value that we just passed to getTranslations. And now we can prioritize this, but in case we don't have a local, we can assign it based on root params. And now if we try our newsletter box, we can see that it uses translations just as we expect. So this is something to be aware of. While this setup is usually all that you need, in case you want to use translations in server actions or route handlers, you can optionally accept an override which helps you to avoid calling root params for these cases. Alright, but that's it. As you can see, we didn't actually change much code in this lesson, but it's very important to have a solid understanding of Next root params, so if you need to, you can customize it based on your needs. In this lesson we'll have a look together at how to implement static rendering for our application. So in the previous lesson, since we're now using a locale segment, we need to provide all of the possible values ahead of time when building our application. And we've already defined the list of available locales in our routing configuration. So to pass these to Next.js, let's hop over to our root layout. And to do this, we can export another function here that's called generate static params. And it returns an array which contains all of the param values that we need. So for example, enus to populate the locale segment. But of course, we don't want to repeat ourselves here, but we already have this list available in our routing configuration. And from here, we can take our locales and map them for each locale to the locale segment value. So this is in fact already the essence of what we need. But what happens if we try to access a locale which is not supported by your application? For example, German as spoken in Austria. In this case, we still see our app rendering in American English. If you remember, in our request configuration, we've assigned a default in case we encounter a locale that is not supported. So while it's good to have some fallback behavior, in our case, we would like to return a 404. And the best way to do this in Next.js is to add another export for dynamic params equals false. And if we reload our app, now we see a 404 just as we expect. Now be aware, we already have defined a not found page for the locale segment. However, conceptually, if we encounter a locale that is not provided by generate static params and is therefore handled by dynamic params false, then implicitly a call to not found will bubble up to the root of our application. You might be tempted to add a not found at this level here, but not found pages rely on a layout being available either as a sibling or a parent. And as you know by now, if we add another layout at the very root of our application, this would break the usage of root params. And that is why, for specifically this use case, Next.js has introduced a new convention for global not found. So if customizing this page is something that you'd like to do, this is the way to go. But for our use case, we'll stick with the default for now. Now let's go back to a valid route. And now let's also try to build our application. So if we look at our build output, all of our routes are in fact dynamic currently. And the reason for it is simply this. We're using the shopping cart feature which reads the browser cookies dynamically and therefore requires dynamic rendering. At the time of recording this video, Next.js is working on partial pre-rendering which would allow interleaving dynamic components into otherwise static pages. So by using something like generate static params, we can already move ourselves into a position of using this feature as soon as it's available. But to verify that our static rendering works correctly, we can hop over to our header. And for the time being, let's comment out this header card and give our build another go. So now the output looks slightly different. We can now see that pages are pre-computed for all of the locales that we support. Alright, but let's revert this for now. So in this lesson, we've explored how we can provide our locales to Next.js in order to render statically. And in addition, we've configured dynamic params equals false, so we can show a 404 page in case an unknown locale is encountered. But there is actually another 404 page in our app which we might want to address, namely the home page. And this is what we'll look into in the next lesson. Previously, we've set up locale-based routing by adding a top-level segment to our app folder. But after doing so, the homepage of our app now renders a 404. So as we've discussed earlier, we could, for example, add a new page like, for example, unlocalized page.typescript along with a corresponding layout and use this page to display a country selection. But depending on your use case, an even simpler implementation can be to redirect to one of your localized variants. And to do this, within our source folder, we can add a new file which is called proxy.typescript. If you haven't heard about this convention before, in previous Next.js versions this was referred to as middleware.typescript. But as of Next.js 16, this was renamed to proxy. What's important about this file is if you're using a source folder, then proxy should live within the source folder as well. Also, it should not be present in app, but instead the only valid position is directly within source. So let's add it. A proxy can act as a thin layer which receives requests just before rendering of the app kicks off. And it can be used to implement, for example, redirects. So let's look into that. A proxy function might look something like this. And it takes a single argument, which is a request, and we can type it as next request. And then we can, for example, return a next response that uses a redirect and returns a URL that points to our enus subpath and is initialized based on request.url. And then the second part is to export a config which defines a matcher, which in our case is simply the application root. So now if I save this file and hit reload, we'll see that we're correctly redirected to enus. So this is probably one of the simplest implementations you can find for a proxy. If you want to be a little bit more smart, you can of course not simply redirect to enus in a hard-coded way, but we can detect the language of the user and respond with a corresponding internal subpath. For this, let's have a look at our developer tools. So if we navigate to the network tab and hit reload here, and then check out the initial request /enus, we'll find that somewhere in the request headers, we see that the browser sends an accept language header. In my case, this is configured for a preference of enus, but also allowing a fallback for German. So to make our proxy a bit more interesting, we could read from our request.headers.get and then use accept language. And this in turn can be used for negotiation to find a corresponding locale to redirect to. But since this is such a common task for internationalized websites, Next.intl ships with out-of-the-box support for this. And to use this, let's get rid of our function and instead use the create middleware function from Next.intl, and as an argument we can provide our routing configuration. And that's it. So now if I go back to my application root, we see that we have the same redirect behavior, but that is of course because my browser has a preference for American English. So let's change this. If we navigate over to sensors, we see that we can simulate a location. And if you look at this drop-down menu, you can see that there are plenty of options here. If you need a custom one, you can of course always add one with the Manage button. For our example here, let's switch to Mexico City. And this sets a latitude, longitude, time zone, locale, as well as an accuracy. It's important to note that the first three of these are only available on the client side. However, the locale affects the accept language header that we saw before. So now if I navigate to the root of my application again, this time I'm redirected to ESMX rendering the Spanish version of our app. Okay, but what if the browser of the user sends a preference for Mexican Spanish, but then the user explicitly changes to enus? Later on, if the user navigates to the root again, we'll again respond with a redirect to the Mexican Spanish version. So wouldn't it be great if we could remember the last locale that the user has used to restore this preference? Also, this feature ships out of the box with Next.intl. However, matching our proxy only at the root is not sufficient here. Instead, we need to be aware of all the content path names that the user accesses, so that we can read the last visited locale from the path name. And for this, we need to extend our matcher. The most common pattern to achieve this currently is to use a regular expression like this one. This uses a negative lookahead, which ignores requests to, for example, API, internal Next.js requests, other internal requests like for example Vercel Analytics, and then we'll make sure to not match any path names containing a dot, since these typically indicate static assets, like for example a fav icon. And after this is done, if I switch back to ENUS, and now I explore the cookies of my application, we see that a next locale cookie is now set to ENUS. That means if we go back to the root, then ENUS is restored. And if we switch to ESMX, then the cookie is automatically updated to this value, so that when we visit the root again, also this preference can be restored. So this is another common pattern that helps you restore previous user preferences. So if you consider which path names are matched here currently, then we'll still match the root of our application, but also a subpath like for example ESMX is still matched. Furthermore, nested path names like ENUS/apparel are also matched. So any path name containing a locale will update the cookie value in the background, and once the user visits the root again, we can apply the redirect. There is one aspect to be aware of here though. So if you're using path names like, let's say, users, and then you have a dynamic segment like for example a slug, a practical value at runtime might be something like this. So if you've paid attention, the dot here in the path name can be problematic for us. And the reason is that we're assuming path names which include a dot to be static assets. So if you're using path names where a dot is expected, a reasonable strategy is to add another regular expression that specifically matches this path name. So here we're matching an optional locale at the start, followed by the user segment, and then any kind of string within this. So since all expressions within a matcher are linked with a logical OR, this ensures that we can still match path names which include a dot. So this might be something to be aware of. Alright, so to summarize, this proxy has helped us to implement a redirect at the root of our application that negotiates the locale of the user and redirects to a corresponding subpath. Furthermore, we've extended it to run on all content routes of our application so that we can remember the previous locale choice of the user to apply this in our negotiation as well. However, it's worth repeating that you can absolutely implement your own middleware in case you have very custom needs. But that being said, we're going to explore a few more capabilities of the Next-Eintil middleware in the upcoming lessons, so I'll see you there. So in the previous lesson, we've set up internationalized routing, which prefixes all of our path names with a locale. Now one aspect that we need to consider here are APIs like link that allow us to navigate between pages. So let's check the markup of our home link. And we can see that it currently applies an href to root. Now as you know, we're using a redirect at root, so when I click on this link, we'll still end up with a path name that is prefixed. But what about other page links like this one here? This link has an href of apparel/man. So what happens if I click it? Also in this case I end up on the correct page. The reason for it is our middleware picks up requests to all content pages, and in case a locale prefix is missing, it will add one. So also if I adjust our path name to stories for example, we'll see that the middleware fills in the missing locale and redirects accordingly. Now while this can help to keep our app running, for example for users who have bookmarked previous URLs, within our app we don't want to rely so much on redirects, and instead we'd like our markup to contain the final href that the user can navigate to. So over in our markup we can find this link that currently redirects to the home page. And of course we don't want to hardcode a specific locale here, but instead we want to use the current locale. So to fix this we can make this a dynamic expression and append the current locale. And now to retrieve the current locale we can use another hook from Next-Eintil that's called useLocale. And now if we have another look at our markup, we can see that our final href is used, which includes the current locale. So this is already better and works correctly, but you can probably imagine we have a lot of links in our application. So adjusting each of these can be quite cumbersome. So ideally we would like to consider the current locale for each of these links, without having to compute them in each of these occasions. And NextIntl can help with this. In our i18n directory, we can create a new module that's called navigation.typescript. And here we can call another utility function from NextIntl that's called createNavigation. And similar to the middleware, it takes a single argument, which is our routing configuration. And now returned from this function, we receive all the typical navigation APIs that you would commonly use in a Next.js application. This includes link, but if we pop up our autocomplete, we can find other ones like redirect, use pathname, and use router. Let's export a few more of these. So that's already pretty much it. If we go back to our header and we revert this change, we can now remove our link import, and instead we can import our new link from i18n navigation. And after this, even though we're specifying an href only for our root path name, if we have a look at our markup, we can see the current locale enus. And if we change the locale to esmx, we'll see that also here the link incorporates the correct locale. And after this, we can also remove the call to use locale in our component. So the link component that we're receiving from NextIntl is really a small wrapper around Next.js link, which considers our routing configuration like the current locale. So after this, we can search for more occurrences of next link. And it seems like we have plenty of occurrences here, and one of them in the navigation link file. So now we can change each of these one by one, but it might be easy to miss one of these. So a helpful tip here that also helps us avoid future regressions is to flag imports from next link. So for this, we can hop over to our ESLint config. And now here we can add a new rule that's called no restricted imports. And this does exactly what it says. When it encounters an import for next link, we can prompt the user to please import from i18n navigation instead. So after this, we can go back to our previous component, and ESLint will tell us that this is not the import that we're looking for, and instead we should import from i18n navigation instead. So let's fix this error and import the correct link. And with this, we have another occurrence fixed. But in our case, we can also simply globally search and replace all imports from next link and replace them with our correct import. So let's confirm this. And now if I check these links here, for example, we'll see that also these use the correct locale prefixes now. So that's already better, but to finish this task, we should of course not only use link, but also the other utility functions. But before we do that, we can modify our ESLint configuration to consider these cases as well. So this time our imports don't come from next link, but instead we can add another config here, this time for next navigation, but only considering the import names redirect, permanent redirect, use router, and use path name. And so after this, if we locate one of our redirect calls, like this one here for example, we'll see again that ESLint helps us to import from the correct location. So let's get rid of this and add a new import from i18n navigation. But this time it seems like we're not quite done yet. Redirect is in fact the only navigation API from NextIntl that is not able to read the current locale automatically. And instead, in this particular case, we need to read the current locale from useLocale, and then we can pass an object to redirect, which contains an href as well as the current locale. And after this, we've also addressed this case. Now one important point to mention here, and you already know this pattern from previous lessons, if this component would require to be an async function, we'll get another hint from ESLint saying we can't call hooks in async functions. So to address this, and you might have already guessed it, we can use await get locale instead. And after this, we're good to go. So this is also the reason why we need to pass an explicit local to redirect. Redirect can be called the same way in async functions as well as in regular components which can call hooks. And since our redirect from nextIntl doesn't know if it can call await getLocal or useLocal internally, we need to provide the local explicitly. But again, redirect is really the only API where this is the case. If we have another look at our header, the link is really a drop-in replacement for Next.js link. So after updating our routing to include the local, there's one piece we haven't updated yet. And by this, I mean the countries list in our footer, or in more technical terms, our local switcher. So let's take care of this. So if we check the implementation of our local switcher, we're currently using this button that when clicked sets a local. And by setting a local, to be more precise, we mean we're setting a cookie. And so earlier we used the getLocal function, which in turn reads from this cookie to make the local available across our application. This was previously done in request.typescript. But here we're no longer using the getLocal function, but instead we're reading from root params and use this to initialize our local. But now what does this mean for our local switcher here? How do we change the local if it's read from pathname params? Well, we already did this earlier, didn't we? If the source of truth for our local is the path name, then changing the local means changing the path name, right? So if we go back to our local switcher, for a simple case like this, we can replace our buttons with links. So let's look into that. So first of all, let's get rid of all of this. And now instead of our button, we can render a link instead, namely the one we've previously exported in i18n navigation. So also these attributes are no longer needed. Now instead, for a very simple case, we can just redirect to the homepage. And now if we check our app, we can see that this link points to the homepage, in this case the Mexican-Spanish version. However, this is also the case for all other items here. So if you remember, the link always uses the current local by default. But we can override this. And for this, we can use the local prop. And in this case, we can set it to local, which is a prop that this component receives and corresponds to the target local of this item. And so after this change, we can see that our links point to the correct destinations. So if I click on one of these, the path name is changed and we have a working local switcher. So with this, you could already call it a day, but we can improve the user experience a bit. If we are on the mens page and we use our local switcher again, we'll of course end up on the home page again. But wouldn't it be nice if the user could stay on the current page? As you might know, the current path name in a Next.js application can be read from usePathName. And here we can use the variant that we previously exported from our i18n navigation module. And we'll see why in just a bit. So to get started with this, let's add some logging. And let's open our console. And here we can see the logs from our location items, and they're simply returning the root path. So let's see what happens if we navigate to the women's page. In this case, apparel/women is returned. So our usePathName returns normalized path names that don't include any local prefixes. And this can be really handy in components to write code in a local agnostic manner. So for our example, we can replace our hard-coded link to the homepage with a reference to the current path name. And after this, we'll see that all of our location items now correctly point to the women's page. And if I click at one of these, I'll remain on the women's page, this time translated to Canadian French. So after this change, we can get rid of our local service since we don't read the local anymore with this function and we're also not setting it anymore. Now here's the most important point from this lesson. So nextIntl doesn't have a function that's called setLocal. If we use local-based routing, changing the local really means using navigation APIs, like for example LINQ. But LINQ is of course not our only choice here. In a similar fashion, we could also use redirect or use router. And in the case of use router, you can also decide between using router.push or, for example, router.replace. The important point is all of these APIs allow you to pass a path name, which can be hard-coded but can also be the current path name if it's based on use path name. And now separately from this, we can optionally provide a locale that we want to switch to. For the sake of this lesson, let's assume that we have three domains available for our project: paradigm.com, paradigm.mx, and paradigm.ca. These domains map quite well to our locales, so if we assign them, we can use enus on our paradigm.com domain, paradigm.mx for esmx, and paradigm.ca for our remaining locales enca and frca. Now NextIntl allows us to adapt our routing configuration to include domains. And here we can provide entries of which domains we have available, like for example paradigm.com, and now we can define which locales are available on this domain, in this case enus. And finally, the third option here is the default locale, which we can set to enus as well in this case. So based on this structure, let's complete the list. So in our case, we have three entries here. Two of these only support one locale, therefore the locales array matches exactly the default locale. However, for paradigm.ca we support two locales, but our default locale is set to Canadian English. So when the NextIntl middleware receives a request, it will receive the host of the request to check which domain the user is visiting. And based on this, the available locales will be restricted to our specific domain configuration. Now, if the accept language header of the user doesn't match any of these available locales, the default locale will be used in response. One important aspect here is that locales need to be unique across all domains. So if, for example, you support English on multiple domains, you should be sure to include a regional subtag like US or CA, for example. But anyway, let's boot up our development server and see what this looks like. And if we open our app in the browser, we see that we end up on enus. And this is because none of the available domains has matched our request for localhost. So in this case, the middleware has used a fallback to the default locale matching strategy. And this uses our browser language as represented by the accept language header and tries to find a matching locale in this list or otherwise fall back to the default locale. So when running the app on localhost, we can flexibly also switch to ESMX or FRCA. So here the fallback behavior can be helpful to flexibly develop our app locally while using these domains when accessing them in production. But before we deploy our app to production, you likely want to verify that this configuration is working. So if you're familiar with local DNS overrides, you can of course use a local domain here to test the locale matching for this entry. However, there's an easier approach here that I would like to show you. So we can introduce a condition here that is called isDevelopment that checks an environment parameter to see if we're running the development server. And now based on this, we can conditionally assign our domain. So if we're in development, our English locale will be localhost 3000. And if we now copy this to our other entries as well, we can use a distinct port number for each of these. And now we can run our development server again, but this time with one of the ports that we've assigned to our domains. And now before I hit save in my routing configuration, I want you to notice that I'm currently on localhost with port 3000 at the Canadian-French locale. With our updated configuration, the port 3000 will only support EN-US. Canadian-French is only supported on port 3002. So let's hit save now. So in the address bar of our browser, we now see that we've been redirected to port 3002. This is the only host where the Canadian-French locale is supported. However, we can switch to EN-CA on this host. So both of our Canadian locales are in this case supported on port 3002. But now if I want to switch back to American English, and I can of course also use our locale switcher for this, we'll see that we're redirected to localhost on port 3000 again. So the URL that we're seeing in the browser address bar here is really the equivalent as if we're browsing on paradigm.com/ENUS. Or if we're browsing on the Canadian domain, we could have path names like ENCA or FRCA. But let's have a closer look together what happens here in the background. So let's assume that the user makes a request to our server. And for this example, let's assume that the user opens paradigm.ca/FRCA. Now as part of this request, the browser will set the host header, which is set to paradigm.ca. In this case, our production server can use the host header to check which locales are available here and to match one of the existing ones. So practically, the locale detection of the server looks something like this. First of all, the host can be read from request headers. Now to determine the locale, the first step is to check if there is an explicit locale prefix like /fr/ca. In this case, we already know that the user looks specifically for this locale, so we're gonna use that. But if the user is accessing the root path name of our application, we need to look a bit further for our locale. So maybe if the user has a cookie set from a previous visit, we could use that. But if also this is not present, we can use the accept language header of the incoming request to see if it's available on one of the domain locales. If also this fails, we can use the default locale of our domain. So this is a sketch of what you might experience for simple deployments of your application. But if you're deploying your app on a more sophisticated setup or managed infrastructure, the user will typically not make a request directly to your server. Instead, the user will hit a proxy server first. What makes this scenario a little bit more interesting is while the proxy receives a request for paradigm.ca, the proxy has to make another call to our origin server. And for this, the proxy doesn't make a request to paradigm.ca, but instead an internal IP address like for example this one here. And in this case, the host is of course also not paradigm.ca, but our internal IP address. And due to this, if we read the host request header as part of our server middleware, we can of course not find the original one that the user has requested. But proxies have solved this problem a long time ago. When forwarding a request, they attach a new request header that's called x forwarded host. And this is set to our original host, which is paradigm.ca. And this is something that our locale detection logic has to consider as well. So in fact, before we're reading from host, the next INTL middleware will read from x forwarded host. And only if this header is not available, we'll use the host header as a fallback. So x forwarded host is an established standard that allows us to identify the original host that was requested by the client. This is commonly used by reverse proxies, for example if you use load balancers or CDNs. But anyway, this is mostly to give you some background information. Modern deployment platforms like Vercel for example, of course set this header accordingly. But if you manage your own proxy in combination with domain-based routing, you want to verify that you're correctly setting the x forwarded host request header based on the incoming request. Alright, well so far so good. But if you're using domain-based routing, there might be one burning question here for you. If you have cases like this, where for example only a single locale is supported on a domain, you probably don't want to use this locale suffix in the path name, but instead simply paradigm.com. Now this kind of prefix customization is exactly what we'll discuss in the next lesson, so I'll see you there. So in the previous lesson we've discovered that if we're on a domain like paradigm.com, which only supports one locale, we don't want it to be present in the path name. And we can achieve just that by adding a new option in our routing configuration. And this option is called locale prefix. So the default here is always. And this means we're always displaying a locale prefix in the path name, and it also matches the structure of our app folder with our locale subdirectory. But we can change this to, for example, never. So let's say if we only supported the US and the Mexican domain, we would in fact have one locale per domain. So in this case, ENUS would be paradigm.com and ESMX would be paradigm.mx. However, in our particular case, we have another domain, and this time it supports two locales. So here the never approach will not work well for us, since it will be unclear which locale should be used on paradigm.ca. And therefore a better strategy for our case is the as needed mode. And I can explore this by reloading our application. So now we see that we're using the ENUS locale while not displaying any locale in the URL. But if we navigate to our locale switcher and switch to Mexican Spanish, for example, the locale will be present in the URL. So as needed means we're only displaying a locale in the URL if it doesn't match the default locale. And if we're using domain-based routing, the default locale can be different depending on the domain. So if I would access my production app at paradigm.mx, in this case also only a single locale is supported, therefore it will be displayed without a path name prefix. However, currently on localhost, since this domain doesn't match, the path name prefix is displayed. So again here, even though we're using domain-based routing, localhost doesn't match any of our configured domains, and therefore we'll fall back to default routing based on our remaining configuration. Now one aspect that's interesting about the as needed strategy is if we previously visited a secondary locale, then as we saw before, this locale is saved in a cookie. But if I now navigate to the root of my application, my previous locale choice will be restored based on this cookie value. So the only way for me to switch to American English is to navigate to ENUS. And we can explore in detail what's going on here by observing the network. So if I hit enter here, we'll see that two requests are being made. The first one was our navigation to ENUS. By navigating to this route, the middleware has updated the cookie and has responded with a redirect. And after the redirect, we can stay on the route because it matches our cookie value. So if we check our cookies again, we'll see that our locale is ENUS now. And in our browser address bar, we don't see any locale prefix. And this is also the reason, if we check our locale switcher, these links of course go to a path name that uses a locale prefix, but also our default locale uses a prefix path name. And the reason for this is precisely to update the cookie value before navigating to the application root. Now if you prefer to not have any redirects at the root, even though we've remembered the previous locale of the user in a cookie, you can set another option here that's called locale detection false. And after this, if I navigate to ESMX and back to our application root, we see that the previous locale choice has been ignored and will display our page in American English. But for now, let's remove this. Okay, now while we can provide simple string modes here, for further configuration we can also provide an object. And here we can use the mode property to configure, for example, the always strategy. But now in this object we can provide another setting. We can customize the prefixes per locale. So now I'm back in the always strategy, and we support English both in the Canadian flavor as well as US English. However, a path name like paradigm.ca/enca seems to be a little bit redundant, right? So preferably I would simply like to use paradigm.ca/en. And this is what custom prefixes are for. We can take each of our locales, like enca, and customize the display prefix to /en, for example. And similarly, for Canadian French, we can use /fr. And if I now support English on another domain, I can again use en here as well. So this path name here as well as this one are in fact unique. And that is because they're living on different domains. So custom prefixes can help me to clean up the URL structure in case I don't need to display a full locale. Another example here could be if you're using a more sophisticated locale, like for example Arab with the Arab numbering system, you can simply map this to /AR, for example. But for our case, let's get rid of this configuration for a minute. And also the domains we've listed here were only for testing purposes. If you remember what we discussed in the planning lesson, we currently only own a single domain, namely paradigm.com. And on this domain, we would like to use regional prefixes like US, for example, or /MX. And now the custom prefixes setting is exactly what we need to achieve this. So in our case, ENUS should be mapped to US. And if we continue like this, ESMX should be mapped to /MX. And then we have ENCA, which we can map to /CA. And finally, our last locale, FRCA, can now be mapped to /CA/FR. So /CA will be used for our English content and /CA/FR for our French. And if we save this configuration, we'll initially end up at /US for our US English content. Now let's check out our locale switcher again. And here we can see that the path names which are used for all of our locales are precisely what we configured. So if I click on Canadian French, I'll end up at /CA/FR. And our cookie will be updated to FRCA. So what our middleware does here is it receives requests for path names which you could call external path names, and then rewrites them to an internal locale of FRCA. So while this is the only path name that's visible to the user, internally our app will be called with FRCA. So it's important to remember, in our app directory, the locale directory always corresponds to an actual locale. Even if we rewrite the externally visible path names, internally they're always handled with actual locales. We've already obsessed over the URL quite a bit, and that's important to do since it's such a critical part of the user interface. But one area we previously left out are path names of pages. So here's our category page for women in Mexican Spanish. And in the URL, we're currently using /apparel/women. So naturally, this is something that you want to localize too. And not only does this improve the user experience of our app, but it's also helpful for search engine optimization. Now to dive a bit further into this, the Google Search Central provides documentation on how to work with URL structures. And the first tip here is to use simple descriptive URLs. And this is already what we're using for our English locale. However, for languages other than English, you should use words in your audience's language. So here's an example for a German path name and another one for Japanese. So by following this advice, we can make sure that our pages rank for these localized search terms. But what's also important to note here is if you're using path names with non-ASCII characters, then you should encode them accordingly. So this applies, for example, to Arab characters, Chinese ones, German umlauts, and also emojis. But what's cool about this is, in this lesson we'll set up translated path names with NextINTL, and if encoding is required, then NextINTL will automatically handle this for you. So as far as you're concerned, you can always work with path names, how they appear to the user. So let's now explore how we can apply this to our application. And for this, our routing configuration takes another property that's called path names. And here we can provide localized variants for all path names that our app supports. So of course, our app has a homepage at the root. But there's nothing to localize about this. So when there's nothing to localize, we can simply use the same value. But let's add a case where we want to localize it. This is our apparel women page. And now here we can provide variations, for example, for our Mexican Spanish locale, to use ropa mujer instead. And if I now reload our page, we'll see that our path name has been localized accordingly. One thing you might have noticed here is that the middleware has automatically redirected to this variant as we reloaded the page. So also if we switch back to US, a redirect will take us to the correctly localized path name. So what happens here is if the middleware receives a request for a localized variant, then it will rewrite the request and map it to an internal route that we can use for all locales. So notably here, we currently only provided a localized path name for Mexican Spanish, and that's why if we navigate to CAFR, we're also using the internal route /apparel/women. So this acts as a fallback for all locales which don't have an explicit value. But we can of course add one for this locale as well. So in this case, and I'll save you from myself trying to pronounce French, we can use this variant instead. And after reloading our page, we'll use a localized path name for this page as well. And similar to this, we can of course also add an entry for our men's category page. Now one aspect to observe here is that since we use the link component from NextIntl, our links to these pages will immediately pick up our localized variants. So all that needs to be done for this is to use link from IETNN navigation and pass an internal href to this link. So behind the scenes, NextIntl will use this path name and check if there's a localized variant for the given locale. And if so, we can link to this page instead of using the internal route as a default. So to double check, if we navigate to Mexican Spanish again, and also here our links have been localized accordingly. Now one aspect that is pretty cool about working with localized path names is that our href here of the link is not just a random string anymore. But instead, we can now benefit from autocompletion and strict validation of all the path names that we use across our application. And one of the cases where this gets a bit interesting is if we have components that wrap link, like for example, navigation link. So here we use our link from IETNN navigation and then forward an href to it. Now our href is currently typed as a string, so that means consumers of this component cannot benefit from autocomplete. But there's a really easy fix for this. Namely, we can use a helper that's called component props and take our link and now from our link use the href. So by doing this, we can use the same strict typing from link and apply it to the href of this component. So if we go to our navigation that renders this component, and let's increase our window size a bit so we can see this component, we can now use strict typing, which allows us to provide one of our known path names to our navigation link. So this is all it takes to work with simple cases of localized path names. But there's another interesting case here. If we go to our product detail page, we're currently still using the English apparel term instead of ropa for Mexican Spanish. And that is because in our routing configuration, we haven't set up a path name mapping for this route yet. So let's take care of it. And here's where it gets interesting. Of course, we're not hard coding the links to all of our available products, but we want to use a dynamic segment like slug. And similar to our previous entries, we can provide localized variants for this one as well. So after saving and reloading our page, we'll end up on a localized variant here as well. But what we still need to handle are links to this page. So if we go to our product item component, for example, here we're currently interpolating the product slug directly into the string href. Now for our link to work correctly, we can turn this into an object and provide our path name, this time with a template that we're linking to, and then we can provide our slug via params. And also here we can get some auto-completion help. Here we're looking for a slug, so we'll assign this with our product.slug. And so if we now go back to our women's page, we'll see that our links point to the correctly localized variants. So that's something to keep in mind. Always when you're working with dynamic segments, you should link to the templates and provide params separately. But let's go back to a product detail page for a minute. And here in the footer, we have our local switcher, which will always link to the current page. And so currently we're on a page with a dynamic slug. So that means if we're on such a page, we should also provide the params separately. So in this component, the usePathName hook is used so that when we change the locale, we'll end up on the same page again. But now with localized path names, we should provide an object here instead, which contains our path name, but also params. But which params do we need here? Well, it should always be the params of the current page, right? So how can we get the params of the current page? We can use params from Next.js. Now the last part that's missing here is TypeScript will ask us to make sure that the params we're providing are ones that can be received by a given path name. Now strictly speaking, if we're on this route, then we should make sure to provide the slug param. And practically we're already doing this. usePathName and useParams both reference the current page. So in this case, and this is very common for locale switches, we can simply ignore this error. So this looks already pretty good to me. Our last step will be to provide path name variants for all of our remaining entries. So let's add them now. And so all of the path names I've added now follow the same schema that we saw before. Usually we want to handle a case for Mexican Spanish as well as Canadian French. And notably, if we're using the Canadian English locale, we'll simply use our default path names which we've defined in English. So this kind of mapping is something you want to keep updated as you're adding new pages to your application. But as a reward for this, we can improve the experience for the user and improve our rankings for search engines. But this is of course purely optional. So if you're building a really large application where defining this mapping can be quite challenging, you don't have to do so of course. So always use your own judgment to decide if localized path names is something that your project can benefit from. In this chapter, I've already mentioned a few times that the Next.intl middleware will save a cookie that remembers the previous locale choice of the user. For some developers, this makes an alarm go off. And the reason for this is they're afraid of the legal implications of using cookies. So in this lesson, we'll have a look at this topic together to make sure we can all sleep good at night. So first of all, how does the locale cookie that we're using even work? So let's get rid of this cookie for now. And next, let's navigate to the root of our application. And now let's have a closer look what happened here in the Network tab. So our initial request for the application root was redirected to /us. And the reason for it is my browser has sent an accept language header with a preference for American English or any English at all, but also allowing German. And based on this, the Next.intl middleware has detected the best matching locale for us and has redirected us to /us. So if we now inspect our cookies again, we actually don't see any cookies used at all. Now the reason for this is there's always one locale that our app supports, which is the best matching one for a user. And if none of our locales matches a preference of the user, we can still fall back to the default locale. So that means if the user again navigates to the root of our application, we will again be redirected to the same locale. So the cookie is in fact only necessary when the user actively changes the locale. So if we scroll to our locale switcher and pick Mexico for example, this time we'll see a cookie value that's set to ESMX so that when the user requests a root again, we can restore this preference. So the important point here is only an active change of the user will set a cookie. So by doing this, we can already avoid setting a cookie for all users who simply browse in their best matching language. And now the second really important point here is the expiration of a cookie. By default, the Next.intl middleware will set the expiration to session. That means as soon as the user closes the browser, this preference will also be deleted. But how does this relate to data protection regulations? So depending on the countries and regions that you support, there could be different laws in place that regulate the usage of cookies. The main intention of all of these is to protect the privacy of users, giving them control how the data is collected and used. And while not the primary target of these regulations, also low-kill cookies can be covered by these laws. To the best of my knowledge, at the time of recording this video, GDPR is the strictest regulation worldwide. So let's have a closer look at this together. If you search for the latest regulations of the GDPR in regard to cookies, you'll find the opinion from April 2012 on cookie consent exemption from the Data Protection Working Party. And this article provides a framework for the usage of language cookies. And these cookies fall in the category of UI customization cookies. And these cookies should only be set if the user has explicitly requested the service to remember a certain piece of information. For example, by clicking on a button or ticking a box. And they may be session cookies or have a lifespan counted in weeks or months, depending on their purpose. And the most prominent example here is a language preference cookie, which is used to remember the language selected by a user on a multilingual website. So that means language preference cookies are generally fine to use if they consider the aspects mentioned below. Now the important part here is if you provide additional information to the user about storing such cookies. And if you don't, such cookies should not be remembered for longer than a browser session or no more than a few additional hours. And if you have a cookie with such a short expiration, you can use them without, for example, displaying a cookie banner because they're exempted under criterion B. However, if you provide additional information to the user, like writing uses cookies next to a low-kill switcher, then you can remember the user preference even for a longer duration. And this is what, for example, MDN does. On their page, if you use the low-kill switcher, they not only give you a hint about the language being remembered, but even an additional control to opt into this. But let's go back to our website and see what this means for us. So currently, our low-kill switcher doesn't provide further information to the user that we're storing their preference. However, as by default the NextINTL middleware only sets a session cookie, this is absolutely fine, so there's no need for action here. And while from a user experience perspective it might be desirable to store the low-kill for as long as possible, it's again important to mention that we're only storing this cookie in the first place if the user switches their low-kill at all. So if users stay on their best matching low-kill, which is United States English in my case, this expiration won't matter in the first place. But projects are of course different, and maybe you don't need to comply with such strict regulations as the GDPR. For these cases, the NextINTL middleware provides an option that lets you configure this, and it's called low-kill cookie. So here we can provide a set of customization options. This is also the place where you can customize the name of the cookie, but for our case the most important option here is the max age. And the max age is defined in seconds. So that means if we take 60 seconds, multiply them by 60 minutes, by 24 hours and 356 days, we can customize the expiration to be 1 year. And so if we switch the low-kill again, we'll see that the cookie expires in 2026, which is 1 year from now. But you can of course also get rid of the cookie completely. So let's start from a fresh slate here and remove our configuration object in favor of false. So now if I change the low-kill again, I can browse the website in Mexican Spanish, but I can verify that no cookie is being set anymore. So definitely use what works best here for you. Depending on the countries and regions you support, how much information you want to display to the user, this can influence the expiration for your low-kill cookie. But for our case, let's go with the conservative default from NextINTL here, which uses a session cookie.